My name's Nico Carver. I'm one of the librarians here at the CFA, and this is our first Climate Lunch and Learn in a series that we're going to be doing throughout the spring. This is a new volunteer group at the CFA made out of CFA staff. We've just been meeting on our lunch breaks over the past couple of months, but there's a sign-up sheet in the back, so if you're interested in helping out with this group, we're welcome to have more volunteers. We have a full agenda for today. Here it is. I'm not going to go through each one because the people will know better what they're talking about. But hopefully at the end we'll have some time for questions and discussions about this group and where we're headed more broadly. I just wanted to give a quick intro. We are CFA staff who think that climate change is really important and we want to do more not just in our personal lives but here at work. The broader picture is that both Harvard and Smithsonian have a lot of initiatives right now that we think we could be a part of. Harvard has a climate action plan that was recently released. It's very ambitious. And Smithsonian, there's a lot of attention because it's the 50th anniversary of Earth Day in April, so they're having an Earth Optimism Summit. Here's just, we have sort of two different ideas for goals for this group. The first is awareness and education. And what we mean by that is awareness and education of what's happening at the CFA, both with CFA science and impacts of climate change on CFA's work. And then secondly, we're interested in taking action, whether that be making the CFA more sustainable, but also getting together and going to rallies and things outside of work. So again, if you're interested in joining, we do have an email group now and a Google group so we can share ideas online. There's a sign-up sheet in the back. Since this is still just a volunteer group, it's all donation-based. So if you did have pizza, you can just do a cash donation in the little measuring cup back there. And then we don't know exactly where this is headed. We know that we have some ideas for events this spring, and we can discuss those at the end of today. But additional next steps about the kinds of direct action we want to do here at the CFA will depend on how many people get involved and different people's expertise. I'm going to turn it over to Natasha and switch out the presentation here.
Hi, I'm the Export Compliance Officer, as you probably know, so I'm not as scientific as many people in this room. But I did attend a few of the inclusion lunches, and I remember the last one, a non-US person got up and said, "I can't believe how wasteful you people are." Was anyone else there? And she really chided us, and I was like, wow, yeah, we are. And so my parents are European. I spent a lot of time in Europe growing up, and you know, things are very, very different in other countries. The way they use their resources, how much they use public transportation. So I have been, you know, exposed to this, and we do have a lot of foreign people here who know how other people live, how careful they are with their resources compared to the US. So that was one of the things that made me think about what are we doing here. And then we do that carpooling survey or the transportation survey every year. And I'm always thinking, so what happens? You know, we do the survey, where's the little pop-up that says, can you carpool? Can you take more public transportation? We have a goal of whatever. I never really see that happen. So I asked somebody in our building, I said, well, what if we want to carpool, let's say 1 day a week? Can we find out who lives near us? Because I do travel an hour, and the person said, Natasha, no one wants to be inconvenienced. And so I was like, wow, you know, I think climate change is going to be really inconvenient for all of us, whether it's, you know, so if it's going to be 100 days over 100 or whatever, it's going to be inconvenient. So rather work on it now. And lastly, you know, we see emails from the sustainability group. I'm not an expert. We actually have a few experts here. Kara and Uma know a lot about this. I don't, but I kind of looked at it. You know, I looked a little bit at the emails, but it really piqued my interest more. I do work with DC and, you know, SAO, and a lot of the projects that I'm looking at are conservation-based. So when all of this is happening up here, it's like, wow, we don't seem to have much of a voice of what's going on for conservation, for preservation. as much as it seems like we should. So when Lonnie Bunch became our new secretary, he did have a all-hands meeting, a phone call. How many people listened to that? Yes, no? A few of us did. Anyway, at the very end, we took questions, and I was capturing the text because I was interested in what he had to say. And one of the last questions are, what are we doing for carbon offsets for our travel? And that was Kara who asked that. I'm like, oh, someone at SAO is asking that. Who is this person? So I got to find out who it was. I knew there was a green team, but I guess it disbanded about the time that I started in 2013. And so in one of his emails, he said since 2008, we've been trying to reduce our emissions. I ask you for help in providing ideas about what we could be doing better, and send it to SI. So I did send it. And I asked him, like, why do we have plastic bags in the stores? How come it's hard to carpool? How do we do that better? That sort of thing. So they called me up, and we've been talking a little bit. So the Earth Optimism Summit was held 2 years ago, but I think we all can understand there's a lot more energy, there's a lot more interest. I think they have 1,500 people planned to be speaking, some remotely, whatever. And Sam Watterson is one of the moderators. You probably know that Jane Fonda has been arrested every single week on Fridays. She moved from LA to make this more of a point. So this happened, I was in France, the IPCC report came out, and it was like, oh my God, I don't think anyone calculated like how many years we have to keep living the way we're living. And certainly I plan to be around the next 12 years. We've got children, we've got grandchildren, and to really see that if we don't stop emitting all these gases, there'll be a tipping point that nature is just not going to recuperate. So I started to get more informed. I took a training at the Sierra Club, and what was shocking was our emission goals were passed in 2008. How many people knew that in Massachusetts? 2008. Have you seen anything different in 12 years? Those are the 12 years. It's been 12 years since we passed these very ambitious goals, and you really don't see anything different. 300,000 more cars coming into Boston than before. So I started thinking, I put solar panels on my roof 7 years ago, but I have oil heat. I'm burning almost $2,000 a year. My neighbor burns $7,000 and burns wood. I'm driving 4 days a week into Cambridge. So I started saying to myself, how do I reach this 45% goal? And I bought a hybrid car. I already reached that because it gets almost 50 miles to the gallon, and it doesn't use gas in traffic, where I'm in a lot of traffic, so it made a lot of sense. We're getting the mini splits in our house. And one thing, we have some suggestions. Something you can do today is change your electric provider to 100% renewable. So there are solar farms, there are providers that's an option, and it's really not that much more expensive. It's like 10.65 cents a kilowatt instead of 10.3 cents. So if you don't have solar, you can change that.
And it's tax deductible. Like my total cost for last year was $56.
Okay, tax deductible. So this is what we want to do, is sort of share the rebates. Mass Save is basically paid by us. We have paid something like $5 in our electric bill. They will come to your house. They'll insulate. We'll talk more about that later. But there's really things that we really need to get going. We know that climate change is affecting us in Massachusetts. I was living in the Navy Yard during this King's Tide storm. The ocean came over where the ferry comes in. The aquarium was flooded, and people from all over the country were calling me, going, oh my God, you know how it is if anything happens, it looks like it's affecting everybody. But it was affecting me in the Navy Yard. And all my neighbors were like taking pictures, thought it was cool. I'm like, oh, well, I gotta sell. I mean, I gotta get out of here in the next 3 years or something. One of the other things, a newspaper article was about Berkeley. We know that Berkeley had power outages, fires coming around, and that affects us. I mean, if we have testing going on in Berkeley and they're turning off the power, it seems like we have to think about, with the Parker probe, it did happen that our instrument was there during the wildfires. And wow, can we do our testing in the fall during the fire season? I mean, has Berkeley done some backup systems? So they were really being impacted as well. So what are the solutions? Vastly improving our energy efficiency in our buildings. Stretch code has been proposed in the legislature. And one of the things I learned is things go into this committee. It's totally non-transparent. You don't know how anyone votes. And at the end of the year, nothing happens. That's pretty much what's been happening. Now, we see articles in the paper that looks like some of the leaders are getting a little more concerned. But in general, it is kind of shocking how you can find out that you're, meet with your rep and go there and then find out at the end of the year nothing happened. And so we really have to not just wait for our government to take action. Basically, we probably know that if fossil fuels went away, we don't have enough power to do all the things we want to do, especially electric cars. So that's where I think some energy independence is important with the solar and other technologies. And of course, revising our agricultural practices. I have like 2-acre front yard. And in the beginning, we didn't mow half of it, but somehow over the years, we're mowing all of it. Whoops. And that's one of the things, we easily can do is bring some biodiversity. We don't have to be mowing all our lawns and, burning all that gas. Okay, so we have some information on the back. As I said, you can switch your electricity. You can get an energy audit. They will insulate your house, and I believe renters, and there's some landlord programs too. And we have sign-up sheets. Nico is working with our Cambridge Rotary Club, and they'll give us some money if we get enough people to do it to do more climate projects. And this is what the one I did just last week. If you have mutual funds, find the ones that are socially responsible. And if you're concerned about fossil fuels, you can speak with your money. Okay.
Okay, next up we have Kelly Chance, who's going to talk to us about tempo.
Should I wear the mic?
Yes. I grabbed the mic.
Oh, yeah, sorry.
I just read this morning that Helsinki has been snow-free all of January for the first time in recorded history. Yeah. So thanks for giving me a chance to talk about my favorite subject, which is tempo. And do I have a laser in? Yeah, there we go. Yeah. So this will be a sort of a briefish overview of tempo. And I see a lot, if not most, of our SAO tempo team in the audience. So thanks to everyone there. So tempo is a Smithsonian mission funded by NASA. It was built by Ball Aerospace, and NASA Langley managed it for us. And this is kind of a who's who of national, international universities and government organizations that we're working with. Especially Mexico, Canada, and Cuba are all being measured by tempo, and we have science teams in those places. And then Korea is doing the Asian version of these kind of rapid air quality measurements, and it will launch, this is called GEMS, it will launch the 18th of this month, or it's scheduled to launch the 18th. So,
Now that's South Korea, right?
huh?
I said that's South Korea, right?
Yeah, but it will measure North Korea and China. We were the first Earth Venture instrument, and we're delivered, and we're hosted, and we're going to launch, we're scheduled to launch mid-22. It's a fairly garden variety UV visible grating spectrometer with 2D detectors. You'll see more later. But it measures the key elements in aerosol and tropospheric ozone pollution, including the precursors and the breakdown products and all those things. And our claim to fame, we are the first instrument specifically designed to measure ozone down here. So, in the planetary boundary layer where we're sitting. And Xiang Liu, who's the deputy of Tempo right there, really made this work magically. We call it the XL method of fitting because XL are Sean's initials. And we are aligned with the Earth Science Decadal Survey and part of a constellation that you'll see a little more later. Oh, and this kind of shows you why it's important to measure at high temporal resolution. The dots are hourly, and most of the satellites in low Earth orbit doing this kind of stuff measure 1 point daily, and if you measure the low once a day, you don't see the high, and vice versa. So we're completed, accepted, delivered, in storage, and we have a host now. We're on a Maxar satellite that belongs to Intelsat, and we will launch on a what's the something? Well, it doesn't matter. So here it is, just as it's finished, and it's now in storage, awaiting integration onto the satellite. Now, this is Joe Weber, you know, and so the satellites we're dealing with so far are in low Earth orbit, so they're about an eighth of an Earth diameter out, so they're zipping around here in sun-synchronous orbits. And then Joe is way out here at GEO, and he's looking at the center of our field of regard, which is more or less Texas and Oklahoma panhandle where they meet. Oh, and also, coincidentally, that's my grandmother's farm was there, so they're no longer with us. So this is what we do most of the time. So we scan hourly from east to west, from Puerto Rico down here up to the Canadian tar sands, Atlantic to Pacific, and you see why we have Cuban and Mexican and Canadian science teams. Now we don't do that all of the time. John Houck, who's heading our Science Data Processing Center, added to the CONOPS a thing whereby, you know, we start in the morning here, and it's dark over there, and vice versa. So when it's still dark over there, we'll scan, and increasingly, once it gets light, we'll do the whole thing, and then at the end of the day, we'll do that. In addition to that, we have up to 25% of the measuring time available to do experiments. Experiments with this means that instead of measuring the whole swath, you measure a part of it east-west. North-south is fixed because that's a dimension on the detectors. So if we see, for example, a forest fire coming up right about, there it is, we could measure a sixth of that field every 10 minutes if it was useful to learn more about fires. And there are other things that I'll show you a bit later that like that. So this is what we look like at the center of the field of regard. We're just over 10 square kilometers. Mexico City, we're under 8, and even up at the tar sands, we're 20 square kilometers, which for these kind of measurements on satellites is wonderfully small. So here are some examples. So in Los Angeles, Greater Los Angeles, we are doing that. These are little squares for our colleagues down in Puerto Rico. That you can't see, they're there, but they're kind of hard to see. We do that, right? And here is the constellation with us going up in 22, the Koreans going up in February, and the Europeans going up 2023 or later. This is an example of the kinds of things we measure. I've actually taken this from ESA's GOM-1 satellite, which we had a lovely involvement with. And we measure these two boxes, and I've labeled most of, not all of the things we measure, but most of them. And I selected out these nice spectra because this is fully cloudy, so it's bright and it's white. Here's why the desert is hot during the day and cold at night. Here's the vegetation red edge, and you can make out that bump. That's the center of the chlorophyll absorption. And then the ocean, when it's clean, is blue and it's dark. And if you go out further, say 2.4 microns, where one of our satellites measured, the reflections can be less than 0.1%, so it's pretty dark. Also, this is what a terrestrial planet looks like, some combination of these spectra. So if you get one of those, you'll know it's Earth-like, right? So there was a NASA study called GeoCape. It never became an instrument, and we're not going to read it all, except that we'll look in at some of the air quality requirements. And there they all are. We don't measure these because we're not an infrared instrument. So CO, methane, and ammonia will be measured by other instruments in other ways, but not hourly like we're doing. Although we'll get back to methane toward the end of the talk. But we do measure those things. And so the only thing left over is ALCH, and that is the plume height of the aerosols. And by the fact that we're automatically co-registered with one of the NOAA GOES satellites, which measure out into the infrared, we can combine the two and really improve the aerosol by having spectral measurements from 300 nanometers all the way out to several microns, and hopefully get that. So here are products. So ozone in the lower part of the atmosphere, where we are, the XL method, tropospheric and stratospheric and total ozone. NO2 is the proxy for the odd nitrogen in the NOx species. Formaldehyde and glyoxal stand in for all of the volatile organic compounds, and then we have SO2 and aerosols. And if you don't know what the list of things you want to measure looks like, or you just saw it a few minutes ago, now you do. So we have a thing called the green paper. It's experiments that we can do and studies that we can do. It's a living document, so it lives there. The first version of it got published in SPIE last fall, and we had lots and lots of nice contributions there. And I want to just mention a couple of things in detail. Of course, air quality and health, UV exposures, so we'll have a UV index. Advanced aerosol products I just mentioned. Pollution from oil and gas fields. Nighttime measurements, resolving the lighting time. I'll show that in a few minutes as a fun example. And then water vapor studies. Several people in our group have made measurements of total water vapor very nicely. In fact, we do as well, if not better, than some of the standard instruments. And that's interesting for a number of reasons. So we'll be able to see atmospheric rivers, like you've heard of the Pineapple Express that comes in to the West Coast, which can carry more water than the Mississippi. And we also have a study coming out on corn sweat. So evapotranspiration from corn. Corn is very greedy for water, and it pipes it into the atmosphere, and that can make heat waves in the Midwest hotter and much more humid. So it's an important thing. Pollution inventories, transport, regional and local, and cross borders. Lightning NOx. NOx come from lightning is an important contributor to the ozone down here where we don't want it. But it's hard to measure, but by doing high time resolution studies, we will be able to look at thunderstorms and into the outflow region and learn more about that. I mentioned the morning and evening rush hour scans, maybe. Cloud field correlation with pollution is an important thing to know because you get more pollution when it's not cloudy than when it is cloudy in many cases. And lastly on here I have agricultural soil NOx emissions. Now, NOx is a precursor of ozone. Farmer spends a lot of money on fertilizer, and he wants it to stay in the ground and go into his plants. But if he does it at the wrong time and the rain happens and other circumstances happen, rather than his plants getting it, the atmosphere gets it and it makes ozone. So he wants it in the ground, we want it in the ground, and that's another study that we'll do.
Can you talk a little bit more about advanced aerosol products? Can you sort of tease that out? What does that mean?
Oh, well, what it mostly means, we want to know how much aerosols we have and we're breathing that are less than 10 microns and especially less than 2.5 microns. So you see PM 2.5 is 2.5, PM 10 is 10. And it's hard for us to measure it by ourselves because we need infrared wavelengths to really make proper inversions possible. We do something but not all. And it's hard for the infrared to do it all by themselves because they need the UV invisible. So doing it together, you know, you have different size particles and different size wavelengths to scatter from them, and you can combine them into better algorithms. Okay? Okay, where are we? Okay, I mentioned the lights. So here are the city lights. Jim Carr, who was our pointing guy, Carr Astronautics, is heading this business. And here is VIRS is an instrument that's already up there on a NASA satellite. And it has one broad band. So this is not a spectrum, it's a broad band. It's the day-night band where they can look at city lights during the dark, okay? Tempo has these two bands, and each one of them has 1K spectral elements. So we have 2K spectral elements to look at city lights at night. And here are light types, and here are spectra. So we can potentially resolve lighting types when we look at night lights, okay? So there are things we'd like to do at night, include that. Doing air quality retrievals either through lunar illumination or with the city lights themselves. Hopefully aerosols and spectroscopy of air glow and aurora. Now, these are all hopefuls. They're not standard products for us, but it's a nice thing to have as scientific studies. Here's where it might help, especially, so low is good here and high is bad. It's the sensitivity of city lights, of tempo alone and with that VIRS instrument. And especially for incandescent lights, if we combine the two, we do more than twice as well as we can do alone. Another little science thing to mention here is that these are OMI data of formaldehyde. SAO pioneered measuring formaldehyde from space, and it's the main proxy for volatile organic compound emissions. So Leju, who is here, and others in our group, developed the method of trading spatial resolution, trading time resolution for spatial resolution. In other words, you measure the same thing many times, but what happens is that when you measure one of those little red boxes, you know where it is much better than you can tell it where to go. So on subsequent measurements, you may be doing this. And if you have the proper algorithm, then you can combine a bunch of measurements into one measurement with much higher spatial resolution. So he did that for formaldehyde from OMI. The OMI measurements are more like that size. And the average footprint size of OMI is about 200 square kilometers. Ours is 10. So we are very hopeful, and we measure more times. So, I mean, we can measure up to 12 times a day instead of once a day, which this does. So we're hoping we can really get down to very, very small resolution in some important places where it's necessary to have that higher resolution. Now, for data distribution, the scientists want to drink from the fire hose, but if you're regional and local and state agencies and other organizations don't want to do that, and they don't want to have to learn how to do that, So we have several tools, and this is the EPA's, the Remote Sensing Information Gateway, which lets you take the satellite data and say, I just want this region, and I want it this often, and I want it on this grid, and I want it in this format, and it gives you that. So that's a lovely thing to have. Let's see. Oh, no, I'm doing good. Two more. So I mentioned the green paper. I mentioned that we can do experiments up to 25% of the time. Studies include the regular hourly coverage or high time resolution coverage for events like eruptions, fires, dust storms, maybe hurricanes. And we will work with experimenters to even further improve the pointing knowledge. They could call it INR in our field, image navigation and registration, by using local landmarks. And we can do these during commissional phase. We'll measure these gases as well, but they're not operational products yet, and we want to make them that. If something's coming along, you know, an event or an experiment where we want to look at high resolution for agriculture or lightning, then we can preload a scan very quickly. And so if you look at that, if you read the green paper, if you have further ideas, send them to one of us. And, one last slide, which is to ask us about methane set. So we are doing an effort. Chong is leading for the Smithsonian, and I'm his deputy on that one. Together with Harvard, we're developing methane set, which is funded, now fully funded, by the Environmental Defense Fund to measure at high spatial resolution methane emissions from gas and oil sources and other natural and unnatural sources. So it should launch about the same time as Tempo in the middle of 2022.
You want to mention there's a TED Talk that you
Oh, yeah. Yes. There's a wonderful TED Talk, and it was wonderful for us because the head of the Environmental Defense Fund gave it. And it was very public, and once he did that, it was too late to take it back. He was committed. So it cost a little more than we'd hoped, but they went out and they found it. So if you just Google EDF methane sat TED Talk, you will find it. And that's what I got today. Yeah. Okay. Roseanne first, and then, yeah.
I was going to, we worry about our footprint in terms of flying, but that's, it's both an event, but each flight is probably a very short event, but you do have these patterns of, flight paths where there are some regions that are very dense in flight paths and others that are less dense. Is this something that you have, I'm not quite sure how the emissions compare with what you're sensitive to, and it sounds like a somewhat different kind of problem, but I'm wondering, have you given some thought to that?
No, I've seen kind of maps where you see, usually you see contrails, but you also will see nitrogen dioxide. I hadn't, but that's a great idea. We'll add it. Don't let me do that.
Super basic question. It looks to me like most of the information that you're getting is from absorption lines. So that's against a background, which presumably varies based on the weather and the terrain and the vegetation cover and all that. So how do you account for all that?
Well, mostly, let me flip back to the spectra. There they go. Here's a good example. But for most of the gases, other than the ozone, we're measuring rather small features, in fact, sometimes very small features, where the background on the surface is not as much of a problem. With ozone profiling, that's more of a problem since we're using broad and different spectral ranges. But it is something we worry about. And we also have to worry about at shorter wavelengths. I mean, this is all Rayleigh scattering. Those bumps there and the stuff coming up is the elastic component of Rayleigh scattering, which is about 4% of every scattering event in our atmosphere. So we have to take all of that into account. But you're exactly right, it can be important.
I have a question which unfortunately your satellite won't help with, and that is the emission caused by transport cargo ships in the oceans. These satellites, all three of them, seem to be focusing on residential or land areas, but we know that there's a lot of emission coming from cargo ships. Are there comparable experiments for looking at the oceans?
Oh yeah, there are a number of papers looking at ship tracks,
Right.
usually in nitrogen dioxide, from the low Earth orbit satellites, so you have to add up spectrum. I mean, we could measure them in our field of regard, which is most of the Caribbean and a lot of the Atlantic Pacific. Certainly the Koreans can do that as well. But for global things, you need global coverage. Hi.
Hi. Is there a thought to work with public health agencies or, groups that are dealing with impacts to human health as well as climate issues, using this kind of data to say, okay, we see the densities of around different cities, and we're seeing different types of emissions of what potential impacts they might have?
Oh, absolutely so. We've had 2 workshops on it already. We call them for our early adapters. Early adapters are mostly people with health interests. And one of them was last fall, and it was organized by the University of Alabama in Huntsville School of Nursing. So the nursing school did us the herd. So health is one of our major reasons for being, and there's a big audience in that now. So we're talking about a meeting with 100 participants.
Okay, sure. Sorry. Go ahead.
Hey everyone, I'm Sang Park. I'm part of Central Engineering. In case you don't know what that is, it's way over there, way at the other end of the world. It's called Cambridge Discovery Park. Do visit us occasionally. I think some of you may have met me. I mean, sometimes I cook food burgers out in the courtyard. But even beyond that, some of you may really know me. I lived in a sailboat right in Boston Harbor for 4 years. Then I got line bounded. Little kids came along. And I'm out there on a ski slope just about every weekend. The reason I'm sharing that with you is I'm out there in the weather all the time. And the things are changing, right? The high tides are getting a lot higher. The snows are not there. Snows are getting wetter when you're skiing, which is not what you want. You want the champagne powder when you're skiing. You want that. Even out in Montana just recently, I was out there, the snow seems to be heavier. Meaning something has to cause that, right? But what I want to share with you is actually Natasha asked me to kind of give you a little talk about the experiences, the weather related. Even though I'm an engineer, I was involved in JWST, but there was a direct impact of how the weather impacted JWST. So I thought it might be kind of suitable to share with you about that. All right, so quick introduction. I think most of you should know what JWST is, I hope. Then there was a whole series of cryogenic vacuum test campaign that I was directly involved in. I was involved in that for almost 5 years. Directly being their program And also I want to describe what the chamber, what the test was performed. You have to see what the test, the configuration was. I mean, it's really interesting why that is all important, you'll see. And of course, we're going to be talking about how this thing called Hurricane Harvey showed up. It was category 4-5. They showed up at the midst of our most important test and critical point. So I'm going to describe a little bit about that, and hopefully we can talk a little bit more after. All right, so JWST. Picture C on the left. Kelly, if you don't mind if I use this, right? Okay. Deploy operational configuration of JWST. And JWST is geared towards IR mission. So what that means is suppress the background. The telescope needs to be down at 54 Kelvin. That was optimized for that. And how to get there is using the sun shield. There is a reason I'm cringing my face on that one. The telescope is big. Telescope is 6.5 meters in aperture compared to Hubble, which is roughly about 3 meters. And also, as you know, it's so big that we can put them into just single launch vehicles, so we have to fold it. So once you get into the orbit, the telescope will be deployed, including deploying the sun shield. It is segmented. It's not a monolith glass. It's segmented, and we actually made it out of beryllium. It's metal. Polished it, put IR coating, which is gold. The reason I'm mentioning about this international collaboration is that it is out there, right? In other words, the exposure is out there. Everybody's watching it. So the optics on top of that, the progress of the mission or the program is pretty significant. It will go, was March 2021, but my understanding is they might be pushing back, but it will go 2021. The reason I gave you that little cringe face was that the issues with the deployment of the solar shield is getting further delay. So that's part of the reason why that 2021 becomes a little gray. And we're going to be way out there. It's going to be out at L2. That means roughly 1 million miles away. Just giving you a little perspective. And that sun shield will protect us. So deployment, the configuration of the spacecraft with respect to the telescope is that sun is looking into it. Sun shield will block it. The telescope is looking the dark side of the sun. And that's the reason for the L2 is it's a very stable environment. And there isn't much of an IR noise as long as we could block the sunlight and the Earth radiance. So it's a good place to be for a type of mission like this. Now a little bit about the test campaign. As I mentioned, with the solar shield sun shield that is deployed, it's actually the size of a tennis court. So we don't have any of the test chambers anywhere in the world. The biggest being in Pembroke in Ohio. Even with that, we could not have tested this entire assembled telescope with the sun shield deployed. So the program made a decision to actually trying to do that at a segmented level, small pieces, and chose Johnson Space Center to have a chamber in there. I'll go into that a little bit. But since you cannot just do the single as you fly configuration, we broke it into multiple test phases, including the commissioning to the final test of the flight telescope. There were 5 tests and multiple tests in between. The first phase was taking 30 days to characterize we had a small Pathfinder telescope in there, testing out. We were learning a lot along the way, including thermal Pathfinder, which was a significant improvement from the first phase. We just put a complex composite in there, see how it behaved, how the test chamber is operating. So there was a significant amount of investment. So this took almost 5 years to get to where we are at the final stage. That happened in 2017. Test chamber. Chamber A was developed during the the Apollo era. So that was in the 1960s, late 60s. And this is actually a historical picture. Lunar landing module with a solar simulator. Actually, there's another picture similar to it, and there is, in fact, an astronaut egressing into the capsule. And they actually close the door, pull vacuum, drop the temperature. You actually got to test out that lunar module with a live person in there. Kind of cool. That was in the 60s, 70s. Since then, we improved it, did a significant improvement into the chamber. And for the purpose of JWST, we actually added a helium shroud inboard of the nitrogen shroud and inboard of the entire outer shell. So that holds the vacuum. Inside is the liquid nitrogen, because the helium shroud alone could not keep it down to the temperature we needed to go. So we sequentially got to cool it and cool it there. And just remember about the why LN2 shroud is in there, because it creates an environment for helium shroud. But I'm going to talk to you a little bit about why that was important and how it impacted us when we were operating. Pretty cool chamber. Spending 5 years on there. So this is the actual pictures of JWST deploy configuration right prior to being rolled in. This picture is the JWST inside the chamber, fully deployed, secondary mirror on the top. Primary mirror, don't forget, 6.5 meters in diameter. Chamber is roughly about 9 meters in clearance. So this is the biggest, probably the biggest chamber you could actually, a telescope you could actually put in there. We had 100 days planned for the flight hardware of JWST. 30 days, it took 30 days of careful planning and sequence that we had to develop over that 3 to 4, 5 years to get us to the final temperature. Why is that as important is that, as you know, as the temperatures are changing, things are contracting, and they're contracting at a different rate. It causes thermal distortion. Thermal distortion causes stress, and stress is big enough, you're going to crack things. You break. So there was a careful choreograph between the thermal, operationally, the chamber facility folks to get us down to the final temperature. And we sat there for about 40 days doing the absolute. That was a plan to have 40 days to operate, checking out all of the telescope functionality. Then it took another 30 days to come out of there.
Does that mimic cool down at the point that telescope?
No.
It's more.
No, actually, cool down there is an environment that's changing. The environment doesn't change. So in other words, you're exposed to it and everything else will be passively cool. So we designed for that. But when you actually go into a test environment, that is different than what we designed to do in operationally. So we had to actually control the gradient that builds within the telescopes. We had to control it. So we actually go slower. So it was very, yeah.
So based on this result, how long will it take JWST?
To cool down finally? Oh yeah, it was gonna take, plan is it's gonna take roughly 90 days to get to roughly to the operational temperature. But of course, we're not just waiting to cool down, we're transitioning out there, that L2 orbit, right? So yeah, so actually the test condition was worse than what we will see in orbit. So we had to design for that. So in other words, we had to control the environment. We can do anything to the hardware, but we actually control the environment that it was cooling down on. So that's why it took 30 days for us controlling that very carefully. But you do want to get there, right? We do want to get there in a timely manner. So even though we're controlling it, so we had a lot of heaters on, we're operationally controlling that to keep it at a gradient that we would like to see. Yeah. All right, so here we are. The telescope is in there. We close the door. Took us 30 days. And during that time, the hurricane showed up. This way started out in Africa. So we actually closed the door about a couple of weeks before this. The ice on the hurricane, actually, it weakened when you got to the middle of the ocean. So we kind of let that go and showed up at a Yucatan, and it regained. That was roughly about a week prior for us to get down to the final temperature, so we had to make a decision whether or not we'll continue cooling, or we have to get it back to the temperature that we could hold it at a safe temperature. So the program manager actually made a decision to say, let's push for it. Took a risk in it. It actually became category 4, and actually became category 5 right before it made the landfall. And hung out there from August 25th to almost the end of the month, almost for 5 days. It hung up there, and actually that's the actual picture. And if you look at this rainfall picture, what you see is Galveston, island of Galveston, Galveston Bay, and that right there in the pink spot is where NASA Space Center is. Of course it did. And why is that important is we actually officially recorded 53 inches. But one of our technicians, when it started to rain, 55-gallon drum got kicked out and left it on a flat ground. In case you don't know, 55-gallon, a trash barrel is 33 inches high, so it's this high. So it's a flat ground, flat rain coming down. We filled that. We tipped it over. Same technician put a yardstick in there afterward, and we measured 18 on those 3 days. So that's 51 inches. Unofficially, we measured that. So it's very close to this here. So how did it impact us is that we got to the final temperature that we needed to do, carefully choreographing getting there, and this thing hit. So our operation was pretty much shut down. I slept on the air mattress for 4 days. We ran out of food, we ran out of water. But just giving you some idea why that impacted us directly was that inside the chamber was 20 Kelvin, or minus 460 degrees Fahrenheit. Outside temperature was 90. The reason I kept that Fahrenheit is that it was a 500 degrees. Sounds more impressive than 250 degrees Celsius. So, why is it a significant event is that, remember what I said about you need to maintain liquid nitrogen shroud at its temperature, because the helium shroud could only keep up with so much of its heat loading being onto it. So we had planned for almost 250 truckloads of liquid nitrogen being driven into Johnson Space Center. Don't forget, this is a 100-day test. What that means is we're getting roughly 2.5 truckloads coming in every day. That's a lot of liquid nitrogen being pumped in there. But when this thing happened, and you talk about highways, highway in Houston is truly highway. It's all elevated. Because why that is a low plane, is flood ground. Any rain you get flooded. So when you're coming off the ramp, you're hitting that floodplain, and you actually do get flooded. So when you have 53 inches of rain on it, the trucks get flooded. So we can bring the trucks in there to be able to keep the liquid nitrogen shroud at its temperature. During that 4 years of planning, we had contingencies to make sure that we have plenty, anticipating that we might get a hurricane or tropical storm. It is Houston in August, after all, so the likelihood of getting a hurricane was there. So we were told that truck is no longer coming in. Project manager came to a thermal engineer, this guy, and said, we need to figure out how to conserve liquid nitrogen. I said, we don't. We had 5 days of reserve because that's what the plan calls for. But what he didn't tell me is that we were already using 3 of those reserves. By the time he got to me and said, figure out a contingency. So we had to scramble. We did it. We came up with a great chart. By raising the liquid nitrogen, yet helium could handle so much heat load, putting a curve on it, technically it was possible. We could keep it by raising the temperature of liquid nitrogen shroud. We're gaining roughly about 2 days, because we weren't sure. We already spent 3 days, so that means we could have a reserve about another 2-ish days. But we took a risk. Technically, on a paper, it looks great. Engineering talk. Practically, things do go wrong. So it was never rehearsed. Even though we were planning for this for 5 years, that was something we never thought about. So we had that on the paper. Pressure was on. Luckily, we didn't have to do it. It was one of the happiest days that I remember anyways, being Johnson Space Center, is when I saw the TV monitor watching one of those trucks finally come in. My understanding is that there was a lot of discussion with the governor of Texas to make sure that happened. Politics. So we made it. But what happened there? Even after all this planning for 4 years, we never anticipated something like that. So anyways, I don't need to go into all that detail. Why, this was a little part of this presentation I made in of all places in Montana during a conference. But one of the things is that even though that we planned for contingencies, but the weather was unpredictable. So I thought it might be worthwhile just sharing that with you. So that's what I have. But I do want to point something out to you. These are the folks that made it happen. We sat through it. We'll look happy, but we weren't. Our hairs weren't exactly. It was over. Just want to point this out to you. It's an old building, remember. Johnson Space Center, the chamber was located in the 1960s, was built in. It's all sheet metal, and with the Houston humidity, everything was rusty. So when the rain came, it started to leak. There's water stains everywhere in the ceiling. And one of those panels actually caved in. What that means is that all of our control panels behind it was getting wet. So in Johnson Space Center, with their wisdom, the best they could come up with was plastic sheeting from Home Depot. But they did give us a rubber ducky on top of it. So we made it through. But it was a very nerve-wracking experience. Anyways, questions?
Since we're running out of time, let's just
Sure.
get to Erica.
Okay.
You just want to give
Oh.
All right. Hi, my name's Erica. I work in the science education department here. One of my many jobs is actually running the communications and public engagement for Tempo. And I want to tell you just about one of our projects that we're doing for that I think hopefully some of you might be interested in getting involved in, but at least know a little bit more about. So one of the things we've developed is a bioindicator garden network. So one of the goals of these gardens is to connect the public to Tempo, and seeing that through the lens of nature. We actually have gardens across the country. We're working on getting towards the West Coast now. If anybody knows any public spaces out there that are interested, always let me know. These gardens are connected at anything from a children's museum to universities to science centers and public libraries. So we're really trying to make them at a place that are publicly accessible for people to get involved in understanding what impacts air quality have on you. So to get these gardens involved, we actually provide them with a number of supports. Everything from setup guides, I actually provide the seeds myself and the plants, to volunteer guides, because a lot of these places have people coming in to help run them out. Signs for the gardens, plant IDs, activity guides, things that they can do to engage their local audiences, and data collection sheets, which I'll tell you about in a second. You can see that's our garden at the beginning of the season there. There's not much growing in it. I'll show you another photo later. But we really want to support these gardens in giving them everything they can to get started in talking about air quality and talking about tempo and how tempo can change our conversation around that. So to give you an idea of what's actually happening in these gardens, you can actually see ozone damage. So a bioindicator garden is a garden that has plant species that show damage, injury from air quality. In particular, ours are ozone bioindicator species. So you can see throughout time, more injury will show up. The most common injury that you'll see on these plants is called stippling. There are these little brown dots that become more obvious throughout the season. It gets more and more common as ozone is in the air, local air. What happens is if the ozone is in the air around the plants, it actually goes into the stomata and causes some plant tissue death. So that increases over time. This is actually a set of plants from Colorado, I think, because more ozone, the worse your injury is going to be throughout the season. So this project, these gardens have individual plants that will show this injury, but also comparison plants. So you can see in our garden we have things like snap bean, where we have sensitive and tolerant species. So you can see a comparison of the plants that have been bred out. That ozone injury has been bred out from them, and you won't see the injury quite as much. And this really gives people a sense to see air quality is such an invisible problem, right? And you go outside, and maybe if you have asthma, you might notice the bad air quality days, but generally you're not looking at it. But if you can see that poor air quality on a plant, the plant injury, it's a little easier to talk about it and wonder, what can I do to change this? So we've actually worked with groups across the country, and this is a group of students that worked with some folks at a Purchase Knob garden to do their own citizen science project. We've also been working with folks at the NCAR, National Center for Atmospheric Research, to turn this into a citizen science project where people can actually collect data on their own and submit it. We're building a new website for data collection as well. So we want people to be able to really connect to the data that the gardens that they're looking at, and then connect that back to some of the work that Tempo is going to do to help us change the conversation. This past year, I just want to kind of stretch this work that we're doing. We've actually connected to Smithsonian's Earth Optimism efforts. And just so anybody that doesn't know more about Earth Optimism, although it is an event this spring, it is also a year-long initiative run out of the Provost's office at the Smithsonian to change the conversation around from doom and gloom to positive. So optimism and opportunity. They really want to change the conversation to what can we do to change things, right? Not just the world is ending, which it's scary, right? There's a lot of problems with climate change, and it can feel like, what can I even do? So the goal of the Smithsonian is to say, here's things that we've been doing, and here's how we can start to make a difference. So for us, we got a small grant to increase our network so more people can know about Tempo and get connected to their local air quality and inspire some of that action. So we're going to be adding gardens to our network, supporting them financially, but also with materials and resources, new signs and things like that. Just a little bit more about what I was saying. It's not just a one-day event, although it is a 3-day event in DC. It's a year-long initiative with events across the country. And if you want to get involved here, if you can't make it to DC during Earth Day, we actually will be growing our garden again this spring. And I haven't set a date yet because, got to figure out when the ground is soft enough to plant. But late April, early May is generally when we plant our garden here on site. And so if anybody wants to get involved in planting the garden, helping to maintain the garden, collect data for the Citizen Science Project, help us talk to the public perhaps about air quality and Tempo and how we can change what's going on with our local air quality. We'll be doing that in the spring. I'll send out an email through this group then as well. So that's kind of just a quick little nitty-gritty about our gardens and how we're connecting beyond the CFA to the work that we're doing here to better understand our climate.
So I think we're basically out of time, but if there's any questions for Sang or Erica?
Can you grow your own ozone garden?
You can grow your own ozone garden, yes. One of the important things though is you don't want to grow it with plants that you buy at like Home Depot or whatever. So if you're interested, you can send me an email. Like I said, our commercially plants are generally have been bred out. Ozone injury has been bred out. So if you want to grow snap beans and look at that comparison, let me know. I've got plenty of snap bean seeds, things like that, and I can get you those plants so you can grow your own garden and make those observations yourself. And I have manuals that will be online shortly so you can figure out how to set it up too.
Great. Last thing I'll say is just we're going to do more of these climate lunch and learns this spring, so look out for new dates. But then also if you're interested in joining our group, there's a sign-up sheet in the back, and you can also send us suggestions for things you want to see. It's just climate@cfa.harvard.edu. Right. Thanks so much.